right, so here we're going to be doing polynomial division. All right, so polynomial division. So we're going to let px and dx be polynomials. I think I use a capitalized D. Your book uses a lowercase d. Not that big of a difference. And so these are polynomials. They're so given a polynomial I want to divide, called the dividend, and what I'm dividing by, which we call the divisor, I'm going to have a unique quotient and a remainder, right? And so these will be unique polynomials. So you can write it in this form. There's another form you can write it, but I don't think your book ever asks you for it, so I won't show it to you. And so let's just let's go through what polynomial division is and how to do it. I think the book assumes you've done it. I'm not going to make that assumption. All right, so here we have polynomial division. What you do here is you're going to try to figure out, I want to get rid of this term. That's what I want to do, right? And I have an x here. And so what must I multiply by this polynomial to get rid of this x? And so if I minus that multiplication, oops, I'm on the wrong layer. Let's switch this to right there. And so here, if I want this to look like this, so here I want this and this to match. So what must I multiply by this by? Well, the answer here is 6x, okay? So I'm going to take 6x, multiply it by this. And so this becomes minus 6x times 6, it is 6x squared, minus 4 times 6. So 4 times 6x is minus 24x. So 6x minus 6x is indeed 0, right? Which is by design, right? And then we go here for the singular x value. Here I'll have minus, so this becomes plus. So minus 26x plus 24x gives us 2x. Then you just drop down the 12. You drop down the 12, and now I have this 2x. What must I multiply by x to get rid of this, or to make it look like 2x? Well, the answer here is a minus, oops, that should be a negative, right? Negative 2x, right? Minus 2x, and so here minus 2. So minus 2 times this will be minus the quantity of minus 2x minus 4. No, minus, not 4, minus 8. But multiplied by negative 2, so this becomes positive 8. So negative 2, which gives us negative 2x plus 8. Let me minus that. So minus 2x is 0 by design. 12 minus 8 gives us 4. And since there's nothing, since this is a degree less than this, we just say remainder 4. Okay. Okay. Remind me at the end of class and I'll mark you. Okay. Okay, so have you guys, just, I guess for my own sanity and reference, have you guys done polynomial division before? Yes, no, vaguely, long time ago. No one's done this before. No and yes. All right, so let me, maybe not sure, yes, but I prefer synthetic. Yeah, so I'm going to teach you long division. I'm going to, maybe in the 1900s. I did it in the before times. So I'm going to just briefly show you how to do this. No one does long division. No one does it this way. But so I'll show you this way roughly twice, and then I'll go very slow through synthetic division because you're only going to use synthetic division. There's no reason to do long division once you have synthetic division, unless you want to do something like this. Okay. So here, let me rewrite everything. So let's rewrite it so I know what is what. And so px in this case was our dividend, which is what I'm dividing from. So that is x squared minus 26x plus 12 is equal to, oops, I did not hold down my button. So dx, our dx here is x minus 4. My qx here is 6x plus 2, or minus 2, sorry. And my remainder here is 4. And so this is dx this is qx, and this is rx. And so when you type this into your homework, it'll be, this is the px, this is the dx, so my qx is 6x minus 2, and my remainder would be 4. All right, so let's do this one more time. I'll go nice and slow this time, and I'll use a lot of space so I make it very clear what I'm doing. So here I'm dividing this by this. So let's rewrite this in division form. We have 8x to the 4th plus 6x squared. But notice here, I don't have an x to the cube, so I'm going to write 0x cubed plus 6x squared minus 3x plus 1. And the reason I wrote this 0 here will become very obvious soon, hopefully. All right, and so when you're tackling polynomial division, let's kind of look at this for a second. Let me talk about it for a second. How to tackle this and how to compute this. So what you want to do is you always want to get rid of your highest term. And so you're going to multiply. So let's pretend I was just doing normal boring division. Say 4 divided by 832, right? 4 divided by 832. What you did here is you did 4 here. So this goes in here. So I put a 4. I put a 2 in here, right? 2 times 4 would give me 8. And then I minus out the 8. I get a 0. I drop down the 3. This goes in 0 times, so I leave the 0, right? Drop down the 2. This goes into 32. 7 times. No, 8 times. 8 times? Why is my brain not firing? Yeah, it goes in 8 times cleanly, actually. This is minus 32, and you get a 0, and then you have remainder 0. That's what we did for normal long division. Oh, thank you. So that's what we did for normal long division. So here we're doing the same thing. Instead of digits, we're going to have terms. We're going to cancel out terms. And so here I have x. I want to get rid of this term. So when I multiply x by to get rid of this term will be 6x. And so 6x times this gives me 6x squared. And then when I do this, I must do this. So this would be minus 24x. And so 6x times x minus 4 gives me 6x squared minus 24x. And then we just minus that from here. So the x squares minus x squares, that gives us 0 by design. Negative 26x minus a negative 24 would be the same as plus 24x, gives us minus 2x. So we just drop that down. Then we pull over, and then we just drop down the 12, kind of like when we drop down the digit. And then here I want to get rid of minus 2x. So what must I multiply this by? Negative 2. And then we multiply that across, minus it out, and we get 0. This is the more complicated way. You guys will not be doing it this way, so I'm not going to go too much in detail. But let's do it this way. But if you have something like this, I hate to break it, once it's not clean, what I mean by clean, like x minus a constant, x minus c. If it's not x minus c, you have to do long division. Synthetic division doesn't work. So this can only be done through long division. Okay. So here, let's do this slowly. What must I multiply 2x squared by in order to get 8x to the 4th? So what am I, I'll give the answer in chat. What must I multiply 8x to the 4th, or 2x squared by to get 8x to the 4th? So think about that and see if you can put it into chat. So yeah. Yeah, so it'd be 4x squared, because 4x squared multiplied by this will give me this. And so here, let me leave a lot of room. Let me use a lot of room here. So 4x squared times 2x squared minus x plus 2 is equal to 8x to the 4th. 4x squared times this would be minus 4x cubed. going to be plus 8x squared. And so this, I'm going to, so I multiply all this, so I'm going to minus all this out from here. And so 8x to the fourth minus 4x cubed. And so have your fourth power. This is why I put in this 0 times x to the third, even though I don't have any x cubed term here. So I just plug in 0 because I'm going to be minusing things from it. So here we put in that x. And then here I'll have plus 8x squared, and I just minus all this across. And so this divided minus this by design is 0. 0x to the fourth minus a minus 4x squared is positive 4x cubed, or that's 4x squared, 4x cubed. So that gives me positive. Here I'll have 8x, 6x squared minus 8x squared gives us minus 2x squared. And then I just pull down this term and just drop it down here, minus 3x. Okay, so now I'm going to do the same thing here. What must I multiply 2x squared by to get 4x cubed? And then we come to find out that is plus 2x. Okay, because 2x will give me this. So I'll do that here. 2x times 2x squared minus x plus 2. Crunch that through. I get 4x cubed, which is what I was trying to achieve. And here, when you add the new term, you'll hit plus or minus. You'll actually write it as a polynomial. So you hit plus or minus. So here, and then I'll get minus 2x squared plus 4x. So I go ahead and plug that in. So it'll be minus 4x cubed minus 2x squared plus 4x. All right, so here, the minus 4x squared minus 4x is 0, right? Then minus 2x squared plus a 2x squared is, again, 0. The minus 3x minus 4x will give us minus 7x. And then we just pull down the 1. And notice here that this degree is less than this degree, so we're done. We just write that as the remainder. So I have minus remainder x plus 1. Okay? And so this is how you do polynomial long division. If this doesn't make 100% sense, don't completely check out. Don't completely check out because we're going to do it a simpler, easier way. But you always just show how to do it the long way first. I don't know why. It's just how we've taught it since time out of memory. I guess I know why. Because if I teach you the synthetic division, as one of my math professors once told me, you're just making alphabet soup. You're just swirling around numbers, right? I kind of want to show you why we swirl around the numbers. Okay, so once again, we can write this the same way we wrote this. And so here, we'll have our, I'm going to go ahead and erase this. This isn't necessary, so I'll go ahead and erase it, just so I have room to type write what I want. So px in this case is our dividend, which is this big beast right here. So 8x to the fourth plus 6x squared minus 3x plus 1 is equal to my divisor, which is what I'm dividing here, 2x squared minus x plus 2 times that's multiplied by my quotient, which would be 4x squared plus 2x, plus my remainder. Notice it's plus the remainder, and our remainder here is the quantity minus 7x plus 1. Okay. All right, so let's do this again. But now, let me leave that up for a second. Let me leave that up for 1 second. So here, so negative 3 plus 4x does make x, but it's negative 3x minus the 4x. And so it'd be minus, so if I move the negative, and it's negative 4x. So negative 3x minus 4x is minus 7x. That makes sense? because we're minusing out what we multiply by. Same thing if I did like, 800 and I'll just write 33 this time. Here, if I did, oops, not square root, but just like a 4. Here, if I did the 4, it'd be 2. This becomes 8, but I minus that 8 through, and I get a 0. This drops down to 3, I get a 0. Then I drop down this 3, and then I get 8, which gives me 32, which leaves me with the 1, remainder 1. And so it's minus this value. And so here we're minusing this value. Yeah, no, it's easy to do. It's easy to do. All right, so let's get to the next one. All right, so we're no longer going to be doing this through long division. We're going to use synthetic division. So we're going to do long division first, and then I'm going to show you what synthetic division is, and then we'll do everything else today through synthetic division. So let's do this by long division. So let's do what I've kind of taught you already. So here we're going to do this by long division. So x squared minus x minus 3. All right, so what must I multiply by this? So if I multiply by 2x, I'll get this back. So 2x times x gives us 2x squared. 2x times minus 3 gives us minus 3, or minus 6x. And then I minus this quantity out. 2x minus and minus 2x is 0. Negative x minus a minus 6 will be plus 6. So this gives us 5x. Drop down the minus 3. What must I multiply x by now, which is 5? So I'll have 5x minus 15, and then minus that quantity out. This gets 0. This gives me plus 15. So negative 3 plus 15 is positive 12. So I have here remainder 12. So this is what we do with long division. For synthetic division, we're going to take x minus c. I guess I didn't write up what we're doing, so let me write it here. You're going to take c, you put it in a cute little box, right? So you take c and you put it in a little box right here. And then you're going to write the coefficients of your divisor like this. So it would be a2, a1, a0, according to what we had way back. I'm going to go way back. Yeah, a long time ago. So, hi, let's go ahead and clear this all away. So here, remember for our polynomials, so a1 is the factor on the first one, a2 is the factor on that one. So here, go back way. So here we have my coefficient here, my coefficient here, my coefficient here. Okay. What you're going to do is you're going to add instead of subtract. When I was taught it, it would be x plus c, and I did subtraction. But this way is better, trust me. So here it would be x minus c. You're going to do a positive c here. So whatever x minus that, you put that there. This is much easier explained by doing it than showing it. But let me give you the algorithm. You bring this down, you hit a2. You multiply this by your c. So multiply by c. You can get a number here. You're going to add up these two numbers. So you get a number here. You're going to add up these two numbers. You're going to get something here. You get another number. You're going to multiply that by c. And you get a number here. And then you're going to drop it down and then get your remainder. Okay? And this right here will be the coefficient. This will be your quotient. This is something isn't the opposite of c? Yeah, so if it's x minus c, so it'd be the opposite. Or, yeah, so in this case, it's x minus 3. And so you just take the opposite of 3. So in this case, we put a 3 in the box. Okay? My coefficients here are 2, minus 1, and minus 3. And just go ahead and do this. And so what you do, and you put a little plus sign here. So here, there's nothing. So we just bring down the 2. We're going to multiply this 2 by 3. 2 by 3 is 6. Okay, then we just add this up. So negative 1 plus 6 is positive 5. And then we multiply this by 3. So this is 3. And this gives us positive 15. Positive 15 plus 3 is 12. And notice here, so this is the coefficient. So 2 and 5 are my coefficients, and this is my remainder. So this would be 2x plus 5. So that's my q. My q of x is 2x plus 5. My remainder x is here is 12. And notice that this completely mirrors what's happening over here, right? Because I get the 6, so minus minus, so plus the 6 gives me this 5, which gives me this 15. And so this mirrors what's over here, but this is way simpler to calculate. So here I get my quotient. So you just read this backwards. This is your constant term. This is your x term. The next one will be your x squared term. The next one will be your x cubed term. And this is your remainder. Okay. We're going to do this a bunch of times. So if it looks a little bit weird after you do it once or twice, with me, it'll make a little bit more sense. When you do it once or twice by yourself, it makes a lot more sense. So let's do it a couple more times. All right. So here I have a negative 3 again. So I just put in positive 3. And then here, I'm going to show you something a little bit different. So my coefficients here are 2 minus 7. Notice there is no x term. So I need to put in a 0. If you do not put in that 0, if this 0 doesn't exist, your problem is wrong, right? And you can get wrong answers. So if you, oh man, I'm on the wrong layer. Layer. So plus 0. So this is plus 0x, right? Just assume it's there. So have a 0 here, and then put a 5. Okay. And so once again, you're just going to take this number, drop it down. You get a 2. We'll multiply 2 by this number here. 3 gives me 6. Negative 7 plus 6 is negative 1. Negative 1 times 3 is minus 3. 0 plus negative 3 is minus 3. Multiply negative 3 by 3 gives us minus 9. And that drops us down to give us, after synthetic's almost fun. Yeah, it's actually not too bad once you get the song and dance. 4. Okay, so let me do this again. So here, I take x minus c. So whatever the minus is, we're going to put that here. So this would be minus 3. So here I put a 3 in this box. I'm going to write my coefficients here. 2 minus 7. There is no coefficient for the x, so I do have to plug in a 0. And then 5, right? Then I'm going to take this, and I'm going to say, here we have, I take the 2, I drop it down. I'm multiplying 2 by the 3, I get 6. Add these 2 up, I get negative 1. Take negative 1 multiplied by 3, I get minus 3. Add these 2 up, I get minus 3. Multiply by the 3, I get minus 9. Add these up, I get minus 4. And then you just read this backwards. So my q of x is equal to, so this is my constant term, so minus 3. This is my x term, so minus x. This is my squared term, so this would be 2x squared. So you read it backwards. And my remainder here is minus 4. P of x here is, this is my p of x, and this is my d of x. So here you have all your parts. Okay. Let's do it one more time. So here I have x minus, I need x minus c. So here I'm going to have x minus a minus 2. So I'm going to put minus 2 here, or you can do what someone in the class says, I don't remember who. You just take whatever the opposite. So if this was negative, make it positive. If this is positive, make it negative. All right, once again, we're going to put in our coefficients. 4. There is no x squared term, so I need to put in a 0. We're going to put in a minus 3 and a 2. And then we just do as we did before. We'll add up. So this 4 just drops down. We get a 4. 4 times negative 2 is minus 8. 0 plus negative 8 is minus 8. Negative 8 times 2 is positive 16. Positive 16 plus negative 3 is a 13. 13 times negative 2 is minus 26. 26 plus 2 is minus 24. And so here I have my q of x is equal to 13. So x squared minus 8x plus 13. So here are my coefficients. And since there's 3 of them, it'll be squared. Here is my remainder. R of x is equal to minus 24. And then once again, this is my p of x. Oops, p, this looks terrible. Let's rewrite that. This is my p of x. This is my d of x. I think your book uses a lowercase. I'll write that at least once. Okay, what's the number next to the 16? Oh, here. So this comes down. This is 13. This is minus 26. Okay. So once again, you just take the opposite of what you're doing, x minus something, or just take the opposite of x, whatever it is. Put it here. Take your coefficients. Make sure to add your zeros. So if there is no x squared term, put the 0 here. Notice here there was no x term, so I put the 0 there. So 4, 0, minus 3, 2. And then you just drop this down, multiply by this, and multiply by negative 2. Add this up, multiply by negative 2, add this up, multiply by negative 2, add this up, and then you're done. All right. Now, is there a way to check your work? Ah, yeah, betcha, right? So let's figure out how to check our work. Yeah, I know. You have been logged out for a while. All right, let's go ahead and hit wrap. Let's type in Wolfram Alpha. Wahoo. All right, now do I remember how to do it? Maybe, maybe not. Let me just see if I can just type it in directly. So if I have 4x cubed minus 3x plus 2 divided by x plus 2. Input. Thank you, Wolfram Alpha. Alternate forms. Ah, here it is, yeah. And here it is its quotient. So you can just type it in directly into Wolfram Alpha. And here we get, here we have our quotient, which is minus 8x plus 13. And this is written in the form the book kind of wants it, except they put qx then dx. I don't know which way. And so this, and then minus 24. And you can check all of them this way. Let's just type in the other one real quick, just for kicks. Because I do want you to check your work. Don't use this as a complete crutch. I know I'm saying that, knowing that some people will. But please don't. Please attempt to learn what you were supposed to learn. Right, and so here's just a way to check it. When I reuse these videos, because I know I will. Gee, it didn't. This one just didn't give me the rest of it. Why isn't? Oh, here it is. Oh man, what's this disaster? Here it is. Quotient remainders, which I was looking for. Here we have our quotient, which we got here, and our remainder of minus 4. Okay. This is just if there's no squared or exponent. Yeah, so this only works if it's x minus c. This only works if it's x minus c. Now why, so why would we teach you a method that only works for, excuse me. Why would we only care? Because at the end of the day, what mainly we choose polynomial division for is to factor really large polynomials. Thanks, guys. So factoring really large polynomials. So if I wanted to factor this, and I wanted to figure out that -2 is a factor, or a 0, right? Remember what our zeros were? Where is that at? I remember listing them. Oop. Yeah, so I remember is that x minus c is a factor. So if I can factor it out cleanly, that means x is a 0, right? That c is a 0. So x minus c is a 0. So I'm looking for zeros. So mainly what we're hopefully trying to do is find zeros. That means this is a solution to this mean a 0. This is x-intercept, and this is 0 polynomial. Remember how important zeros were? And so the whole reason we do all this mess is right here. So let's pretend I have this big polynomial, and I want to know if minus 2 is a 0, right? So there's two ways of doing this. I can plug it in directly and see if I get 0 out, right? Or I can divide by x plus 2, so it'll be x minus a minus 2, right? That'll be x minus c. And see if that factors cleanly, right? Because that's the point. We want to see if we can get clean factors. And so let's do this. And so the remainder theorem is what your book is talking about. If I x divided by c, the remainder, and if I divide p of x by x minus c, the remainder is the value of p of c. And so sometimes if I want to find out like what x, and so it's also a very fast way of plugging in values. So this one, 2 is not a factor of this, and I could have probably told you that beforehand because I know things that you don't, right? 2 is not a factor of this. I'll show you those things tomorrow. But let me just show you through the remainder theorem that we can have done this. So here, so let's do it 2 ways. We're going to plug it in directly, and then we're going to calculate it. So here, if I did this, I minus this, or this is my c is 2. Here I'll have a 3, I'll have a 5, I'll have a negative 4, so 5 minus 4. There is no x squared term, so there's a 0. And then a 7, and then a 3. And so we'll just go ahead and crunch through these numbers. So drop down the 3. 3 times negative 2 is minus 6. Add these up, I get negative 1. Negative 1 times minus 2 is 2. Add this up, I get negative 2. So negative 4 plus 2 gives me negative 2. Multiply by negative 2, I get minus 2. Add this up, I'll get minus 2. Multiply by negative 2. Oops, I missed something, didn't I? This times negative 2 is not negative 2, is it? This is positive 4. Positive 4 added up here. Then multiply by negative 2 gives us this. Add this down, I get minus 1. Negative 1 gives me positive 2. Add that is 5. And so what I know here that p of minus 2 is equal to 5. That's what the remainder theorem says. Whatever your remainder is, if I plug this value into this function, that's what I would get. Now we can calculate it directly. So here I can have 3 of minus 2 squared plus 5 times minus 2 to the 4th minus 4 times minus 2 to the 3rd plus 7 times minus 2 plus 3. All right, let's see if we can crunch through these numbers. It's easier to work backwards when you do this. So this will be plus 3. This will be minus 14. Oops, that's a negative 2. Negative 2 times 3 is minus 8. Minus 8 times negative 4 gives us positive 32. Oops, 32. So if this is minus 8, this is positive 16. Positive 16 times 5 gives us plus 80. So if this is positive 16, this will be minus 32. Minus 32 times 3 would be minus 96. Okay, so let's just crunch numbers from here. This gives me, that's the fastest way to do this. Gives me minus 16. This gives me positive 16. This gives me positive 2 plus 2, which is 5. Okay, so there you go. We did something as if we're on a desert island. Isn't it supposed to be positive 2? No, if I'm plugging it straight into the polynomial, I want to find what p of negative 2 is. So this is really x minus a minus 2. And that's why I put the minus 2 here. Okay. So I want to find out what p of negative 2 is. And so both of these equal 5. And so this is a fast way if we didn't have a calculator to figure out what it was. Now, since we all have calculators, we just go to Wolfram Alpha, type it in, and presto, we get an answers and move on to our lives. But I have to teach this to you. It's my job. It's literally in the definition. Okay. All right. Let's just do this last little bit and then we'll do a cleanup tomorrow. So I'll do some factoring by grouping. We'll work on the homework tomorrow a little bit. And then we'll do some just-in-time stuff for Thursday. And I'll write those notes either tonight or tomorrow. Okay. All right, so here we want to put, so the main thing is we want to figure out, is this a factor in two ways? So we can either divide it or plug it in, right? So x minus c, notice c here is equal to 1, right? Now plugging it in is really not that bad, right? And it's really easy to check if 1 is a factor or c equal to 1 or x minus 1 is a factor, because what do you literally do? You just plug in, you just add up the coefficients, right? Because 1 squared, 1 to the 4th is 1, x to the 3rd is 1, x squared is 1. It's all just 1. So it'd be, the coefficients here is 1, minus 3, minus 13, plus 15. And if I add all this up, I get 0. So yeah, that's a factor. Right. Or another way of doing it is we could do our division. So our c here is 1. So x minus c, so 1. So I have 1 minus 3 minus 13 plus 15. And then since I don't have a constant term, we'll put a 0 here. So this is 1. This is 1. This becomes minus 2. Minus 2 is still minus 2. So this is minus 15. So this is still minus 15. Because multiplied by 1, we just get the same thing back. This is 0. So this is 0. So this is 0. Okay. And so here we have a 0 remainder. That means that cleanly factors that. Now, here, the benefit of, instead of just plugging it in here, is I know what the reduced polynomial is, right? I know what the reduced polynomial is here. I have 1, 2, 3, 4 terms here. And so it'd be x minus 1 multiplied by x cubed minus 2x minus 15, 2x squared minus 15x plus 0, right? Plus 0. But here I can actually, if I wanted to, and this is the whole point, I could factor out the x at this point. And then I get x squared minus 2x minus 15. And then if I wanted to finish factoring it, here this is, which implies I can have, oh no, just equals is fine. X minus 1, x, if I factored this is x plus 3, x minus 5. Yes. And so here I completely factored this polynomial. All I had to know is that I guess this is a factor. And once I factored that, I can pull out an x, because you know how to do that, and then you can do this. And so here, this really, really large polynomial, technically we just factored the whole thing, because I did synthetic division here. So I know it's x minus 1 times this is my quotient. And so I have 4 terms, so I know it's x cubed. So this is x cubed. Usually I write it backwards. Usually I write plus 0 minus 15x minus 2x squared minus, or plus x cubed. That way, just the way I work it. Okay.